Which of the following is the power of the engine? Power is force times velocity. So it gives us the answer of B. Average magnitude of the force. Force is change in momentum over change in time. So initial momentum is mv1, which is equal to 0.4 times by 5, which is 2. And final momentum would be mv2, 0.4 times by 3. But as this is acting to the opposite direction, there should be a negative sign in front. So it's negative 1.2. So delta P would be 2 minus 1.2, so it's 3.2. So the force would be 3.2 over 0.2 here in the question. 0.2 would be 16 newtons. Okay, the object is projected upwards like this. In the same point above, like this. So here and here is t equals to 2, and here is t equals to 8. So assuming it has traveled in the perfect parabola, the time when the object is at its maximum will be t equals to 5, because 3 seconds going up, 3 seconds going down like this. So t is 5, and at this point the velocity would be 0 because the direction is changing, and it stops at the maximum point here. So t is 5, v is 0. So we are going to calculate initial speed. Acceleration is negative 10. So v equals u plus at. V equals to 0. U we don't know. And negative 10 times 5. So u equals to 550 meters per second. Okay, net external force. Force is equal to delta P over delta T. Change in momentum. This is also equal to SP is mv, m delta v over delta t. And as here, t refers to the rate of something. And in here, it's the rate of changing velocity. So, yeah, rate of change of velocity here. This question, again, is about the definition of equilibrium, where F net is equal to 0. So it's the no external forces. No, so this should be C. F net is equal to 0. A lift is operated by an electric motor. Okay, and the important bit here in this question is a constant speed. And as the kinetic energy and the V is not changing, the kinetic energy would not change. So no kinetic energy, no. So it gives us the answer T. Okay. And this question is also about the definition of equilibrium, the conservation of momentum. As there's no external force acting on the system, the momentum should be conserved. So the total momentum of the system has not changed. So speed is distance over time, which is the gradient here. So distance is delta y-axis, and this is distance delta x. So it's time here. So it's the gradient. Okay, so the distance ut plus half at squared, but as it was initially at rest, u equals to 0. So it's like this. As the distance is 16d, so they're using a d as a distance. So d. So now it changed to 16t half at squared. So the time should be multiplied by 4 to get the 16. So 4t squared, 16t squared, and 16 can be matched with this. So it should be 4t.